G'day prospective vatSim air traffic controllers, and welcome to a concise introduction to the advanced ATC client vatSys. vatSys is based on the real-world EuroCAT air traffic system and is an excellent client that's both intuitive and offers many powerful tools to controllers. This video is broken into two parts. First, I'll demonstrate how to connect as an observer. Then, I'll introduce the functions of the client that's relevant to S1 and S2 students. Both parts of this video are important if you're observing for your S1 rating, as you need to understand how vatSys works for your observation to be valuable. Your observation hours are an incredibly important part of your training, and we do recommend that in order to get the most out of it, you take notes, write down any questions you may have, and use the opportunity to build familiarity with the client. Please note as well that not every controller is perfect. In fact, probably no controller is perfect on the network. So don't take everything as complete fact when you're observing. Controllers will make mistakes and will have certain bad habits. So it is important to recognize that when a controller on the network does something differently to the course or the SOPs, the course and the SOPs should be your primary source for procedure and phraseology. If this is your first time opening vatSys, you may be prompted to select a profile. If you erroneously select the wrong profile, you can return to this selection screen through Settings and Change Profile. Of course, we'll be using the Australia profile if you are using vatSys to control in the VAPAC region. The first thing to do once you have your profile selected is to have a look at the vatSys settings. Starting with display settings, there are a bunch of different settings here. These are largely personal preference and you can adjust these as you see fit. If you have different screen sizes and find it difficult to read the text in vatSys, you can change the font size for labels, maps. You can change the brightness of certain elements of the display. That's certainly an option. The next setting to look at is the audio settings. Make sure that you have configured your microphone and output device correctly, and you can adjust the volumes for specific parts of the client here. So obviously when you start controlling, ensure that your input volume is correct so that you're generally in the green area. And the air-ground volume will be the volume for pilot communications over the frequency. The ground-ground volume will be the volume for controller coordination. So that's when you're using the hotline or cold line functions in vatSys, where you can talk directly to other controllers for coordination purposes. You can also adjust the volume of alerts, such as the conflict alerts or the route alerts. You'll learn about these throughout your training. And you can adjust the volume of the VSCS tones. Again, all of these things you'll build familiarity with when you actually do your rating, but it's good to just get started with the air-ground volume adjustment so that you can hear pilots properly when you're observing. You also have the option to configure additional audio devices, and you can set these up as a speaker, and we'll go into how to use that in this video. But essentially the speaker should be designated for things like monitor output devices or other speakers that are on your desk that aren't your headset, if you do want to use that for realism purposes, or if you're away from the computer for a moment, you can toggle all of your output to that speaker so you can still hear vatSys while you're away. When you come back, you'll be able to get on top of any transmissions you may have missed. So once we're ready to start observing, having set up your settings in vatSys, the first thing you'll want to do is set your position. You can do this through settings and position. So if you're observing, for example, Sydney Tower, that'll be under Class Charlie Tower, Sydney Tower. Most of the major towers in Australia will be a Class Charlie, for example, Melbourne, Canberra, Perth, Adelaide, Brisbane. All of those towers are there. Just click the one that you want to observe. Once you set a tower position to observe, you'll notice that the OzStrips window pops up. OzStrips is a newly mandated tool that replaces the default vatSys strips for aerodrome positions. So that's for delivery, ground, and tower controllers. And all training will be conducted with OzStrips now as the primary strip methods for aerodrome positions. OzStrips is highly customizable, it's highly flexible, it can be altered to the specific position you're controlling. So you don't need to see every strip in the aerodrome if you're just controlling delivery, for example. The strips that have already received clearance and are taxiing or on the runways, you don't need to see those strips. So it is really effective at saving space, even though the window does look larger than the original vatSys strips. Once it's configured, it will allow you to save space on your display, particularly if you only have one display. That's highly beneficial. So because we're using OzStrips, the ADEP YSSY, or the ADEP whatever aerodrome ICAO code you're observing, this bay here, this is the departure strips for that bay, the default vatSys strips. We don't need this, we're not going to use it for training, so you can close this bay. Now it's time to configure the look of our display for observing. This is largely personal preference. If you're observing for your S1 rating, the most important thing to look at are the OzStrips window and the vatSys SMR, the surface movement radar. That's the ground window. So what I like to do for ground positions is simply split my screen in half like this, where I've got OzStrips on one side. And I do like to keep it so that I can still see that top bar there, because that does have important functions to access while you're observing or controlling. And then under Windows, ground. And this is the same if you're observing tower positions, you'll still need the ground window so that you can see your aerodrome. So you may choose to do something like this. If you do this, you obviously lose view of the air window, which is behind this, and that shows any aircraft on final. So if you are observing a tower position, this is an important window to see. You can open a secondary air window under Windows Air, and then setting the position. So if you have multiple displays, you can move this secondary window to a different display and use this for your tower observation. But if you are just observing for S1, you probably are largely focused on the ground window and OzStrips window, because you won't be controlling the runways or aircraft on approach as an S1 controller. You'll be controlling ground or delivery positions. Once you have the ground window open, on that ground window, go to Position and choose your aerodrome. And then you should be able to see the full ground map for the aerodrome that you're controlling. In your profile, it's unlikely that the taxiway labels and the runway labels will be activated by default. You can toggle these on under Maps, and by selecting the Taxi All map and the Runway All map. You can also activate bay numbers by selecting the Bay Numbers map, though it's probably not necessary to have the bay numbers on at all times, as they do add quite a bit of clutter to your display. The other window that you'll absolutely need to see while you're observing is the VSCS window. This window allows you to manage everything related to frequencies and controller coordination. So it's called the voice switching control system. Anything regarding communication will be done through the VSCS window. You'll also need the ATC window for the specific aerodrome you're observing. This should open by default, but if it doesn't open, you can go to Windows, ATC, Request, and then type in the aerodrome. For example, Sydney, YSSY, and this window should pop up for Sydney. Once you've set up your windows, it's time to connect to the VATSIM network for observation. So if you go Settings, Connection, this is where you can fill out all of your details before you connect. So you'll need to set your real name on VATSIM. This is the name that you have used on VATSIM. Shortened names are allowed. You can also just connect with your CID, your VATSIM ID, if you don't want to use your real name and have that displayed. You'll need to enter your VATSIM ID. You'll need to enter your VATSIM password. Set your position to OBS. Set your rating to OBS if that is your rating. If you have a controller rating, you can set that. Set the server to automatic. The range will automatically fill based on the position that you have connected, so don't change the range. And then finally, set your call sign to your initials _OBS. If this call sign is taken, so for example, if someone else has logged onto the network as ABOBS in my case, you can connect with __, your initials __OBS. Or you could use your middle initial for your middle name and connect with that instead. You can remove the controller info that fills in. That's for controllers who are connected to the network. So once this is all set up, you can click connect, and you should start to see traffic populate in OzStrips and in the ground window. You can close the connection window once you've connected. If you don't see any traffic on your ground window or in OzStrips, and you know that there is traffic at that aerodrome, for example, you can see aircraft on the ground using vatSim radar, but just not in your client, that could be because your visibility range hasn't been set properly. The client, vatSys, will automatically set your visibility range if you set a position before you connect to the network. Once you're connected to the network, if you go and change your position by going settings position and choosing a different tower, your visibility range won't automatically move. So if you do want to change your position, make sure you disconnect from the network, set a position, then reconnect to the network. So if you don't see any aircraft on your ground radar and you know aircraft are there, the best fix is simply to disconnect, reset the position that you're trying to observe, and then reconnect to the network, and that should fix it. Now that we're connected, in order to listen to the ATC that we are observing, we'll need to use the VSCS. So head down to your VSCS window. By default, it'll be on the coordination page. Move up to setup. So we want to add a frequency. Then just enter the call sign of the frequency that you'd like to observe, for example, Sydney Tower, and click add. The frequency will then show up here on the left with the actual frequency itself. So Sydney Tower is 120.5. Click on that. Then click receive. And now we're receiving on the Sydney Tower frequency, and you should hear transmissions from pilots and controllers. If you want to turn it off, just go back to idle. You can add multiple frequencies. For example, if I go back to setup, I want to observe Sydney Tower and Sydney Ground. I'm going to add Sydney Ground. And there we go. I can now receive on Sydney Ground as well. Now we'll move on to the second part of the vatSys observation video, where I'm going to talk through some of the features of the client that's relevant for your S1 observation. So the most important window for S1 is the SMR, the ground window that shows all of the aircraft on the ground at the aerodrome you're controlling. During busy periods, you'll have lots of aircraft, and you'll see lots of these blue tags for the aircraft. If you want to move those out of the way so you can see them better, simply right-click the radar return, and you can move the tag, then right-click to set a position. So it's just right-click, move, right-click. Blue aircraft on the ground are departures. Orange are aircraft that are not yet squawking mode Charlie. And yellow aircraft, there's none at the moment, but we might see some soon, are arrivals. You'll notice that there are some radar returns on the ground window that don't have an associated tag, such as this one here. This is simply an aircraft that is not yet squawking their assigned code and mode Charlie. You'll notice that the tags themselves show the runway assigned to the departure aircraft, the wake category of the aircraft, and the aircraft type. So we can see that Qantas 530 is assigned to runway 16 left. It's a medium weight category, and it's a Boeing 737-800. You can also move around the ground window. You can zoom in, zoom out, move around as you please to align it to the specific position that you want. All of the keybinds for this will be available for your specific client in settings and keyboard settings. So you can see here pan up, pan down, pan left, pan right, range increase and range decrease are all defined for me. These will likely be different for you. The default keybind here, which for me is the home key on my keyboard, will also just return your display to the default. Another tip for using the ground window is if you do want to have a more enlarged view, such as a view of the bays at Sydney, you can open a second ground window. Just go Windows, Ground, set your position, and you can zoom in further on this second window. For example, if I want to see the bays at the international terminal at Sydney, there we go. That's an example of using a second ground window for a more enlarged view, and then having the main ground window where you can see the entire aerodrome that you're controlling. Another tip for the ground window is if you're not as familiar with the aerodrome, you may not know which direction is which, as this is not always oriented north up when you select a position. If you go position and free, that will orient the display north up. Now, it's definitely not recommended that you use this for observing the entire time or for controlling, because you'll notice that when I select the free mode of the ground radar, I lose the color coding for my arrival and departure tags. I lose all of the information about aircraft type, weight category, and runway assignment on my departure tags, and it's all just replaced with these little orange tags that just say the call sign. So definitely don't use this when controlling, but if you do want to see the orientation of an aerodrome, you can set it free and then set it back to position. For example, at Melbourne is not north up. If I set free, you'll see that the display north up looks very different. One good way that you can still remember which way is north up is by using the free text field in vatSys. That should be the F9 key on your keyboard, but if it's not F9, just check the keyboard settings and look for free text. And you can use that to create a little compass rose, because you can type anything in these little free text fields. There we go, and I might even put a little asterisk above north there. If you want to move those text fields around, just right click them and you can move them anywhere. So once I've made that little compass rose, if I set my position back to Melbourne, that compass rose will stay there, but it'll stay pointing the correct direction. So now you can still use the correct view, but you now have a little compass rose that just reminds you what direction is which, so that, for example, if you're giving pushback approvals and you're telling an aircraft to push back tail west, tail east, tail north, whatever, you know what the direction is and you don't make a silly mistake by thinking that it's north up even though it's not. That's not a major issue at Sydney if I go back to Sydney, because it's basically north up anyway, it's just off by a couple of degrees. So that's the basics of the ground radar. Now let's have a look at the OzStrips plugin. So OzStrips is a really great plugin. It really improves a controller's ability to spot mistakes in flight plans. It improves the controller's ability to manage workload, and it makes your controlling much more efficient. But there's lots you can do with it and there's a lot to get across. So we highly recommend you read the OzStrips documentation. This is a great opportunity in your observation hours to become familiar with OzStrips, because learning these strips will be a big part of your training, and the more prepared you can be for your training, the quicker you'll be able to finish your actual mentoring. So just note that while you're an observer, you can move any of these strips around and it won't affect what the controllers see. None of the changes you make as an observer will affect what controllers are doing. The first thing you might want to do if there aren't any strips showing is just ensure that the aerodrome is set correctly. You can just go aerodrome and then type in the aerodrome or click it if it's showing up there. You can also change your view if you're just observing a specific position. So if you set your view mode to SMC, which is ground, that's going to remove the bays that are only relevant to tower controllers. Now looking at the actual strips themselves, there are a couple of things to note. In the center is the call sign. You can click that and then click a particular bay if you want to move the strip somewhere. If you want to move the strip to the next bay in its sequence, just click the SID, the green SID, and that'll SID trigger the strip forward. So in this instance, tie 472 has just been moved from the pre-active to the cleared bay. I can click the SID again, that'll move them to the pushback bay, etc. Now moving from left to right on the strip, this bay here is for the bay number of the aircraft. If they're at bay domestic 1, there we go, I've just inputted domestic 1. Below that is their destination aerodrome. Above that here, that is their estimated time of departure in their flight plan. Then their aircraft type. This aircraft is an A350. The wake category of the aircraft. Their squawk code. If this has 4 X's, the squawk code is not assigned. To assign a squawk code, just click those 4 X's. The call sign. The assigned runway. The bay below the assigned runway is for when the aircraft has reported ready. When they report ready, just click that and it'll display ready. This field here is for the holding point. Once the aircraft has been issued taxi instructions to a particular holding point, you can type that in there, for example, Alpha 1. The assigned SID. If the assigned SID here has a yellow outline, such as this Rook 1, It means that SID has a transition that needs to be issued in the clearance. You can hover over the SID and it'll tell you the transition. So when you're issuing the clearance, make sure that you don't just say Group 1 departure, but you do say Group 1 departure KDOM transition in this case. Then below that is the first waypoint of the flight planned route. So this aircraft is planned via KDOM. In the top right, that's the RFL, the requested flight level of the aircraft. So this aircraft is requesting to cruise at flight level 390. Below that is the CFL, the cleared flight level. So if you're controlling ground or tower, you'll just put the initial altitude for the aerodrome. For example, at Sydney, the initial altitude you'll give to aircraft is 5,000 feet for jet aircraft, 3,000 feet for non-jet aircraft. At Melbourne, it's 5,000 for everyone. Every aerodrome has SOPs that describe the initial altitude. Make sure you check those SOPs, particularly for your training, because your instructors will want to see that you know the initial altitude that you're supposed to assign to aircraft. Below that is a little stopwatch you can use as a controller. If you just click on that stopwatch, it'll start counting seconds. This here is the global remarks bay. Anything in that bay can be seen by every controller. And the bay to the right of that is the local remarks bay. You'll also notice that OzStrips has a number of very helpful prompts when there are incorrect information in an aircraft flight plan that you need to notice as a delivery controller. For example, the red box here, if you hover over that, it'll say potentially non-compliant filed cruise level detected. That means that this aircraft, Thai 472, they're tracking to the west via KDOM, but their RFL, their filed cruise level, is flight level 390. When tracking to the west, aircraft are required to file even cruise levels, and obviously flight level 390 is an odd cruise level. So as a delivery controller, the correct response to this particular error message on OzStrips would be offering the pilot flight level 380 or flight level 400. Now we'll move on to the flight plan window. We already discussed how you can open the flight plan window by clicking on an aircraft's call sign on the ground radar and then clicking flight plan. But you can also just click on the aircraft type in OzStrips and that will open the flight plan window. I'm going to use Qantas 846 here as an example. This is an example of a flight plan window. Top left will display the call sign. Below that the aircraft type and the weight category, equipment codes, the flight rules there. If it's I, it's IFR. If it's V, it's VFR. The departure and destination aerodromes, as well as the aircraft's filed alternate. The estimated time of departure, actual time of departure. The ATD will fill in once the aircraft actually departs. And the estimated elapsed time, so that's the estimated flight time. The TAS, the true airspeed, is the filed cruise speed of the aircraft. And the RFL, requested flight level, is the filed cruise altitude. Below that is the route. You'll see that Qantas 486 has filed via Ulster, Yankee 193, Banda, Hotel 252 to Brisbane. And the controller has assigned the Kevin 7 departure on runway 16 left. So the Kevin 7/16 left, or any SID/runway, that is assigned by controllers in Australia, so pilots shouldn't file that in their flight plans. Of course, some pilots do, not everyone knows this, but most pilots won't. And the star as well, so if they're cleared for a star, it'll display in the same way, star/runway. Below that is the remarks section of the flight plan with additional information. Down here is extra information about the aircraft in the client itself. So this is not part of the aircraft's flight plan, but rather information that vatSys and ATC either knows about or has entered into the aircraft strip or tag. So you'll see the state controlling sector. These are only relevant when you progress to your S3 or C1 ratings. The SSR code. SSR stands for Secondary Surveillance Radar. SSR code is literally just the squawk code, so this aircraft will squawk 4224. The label data, that is the text that displays in the aircraft's label or their tag. You'll see the CFL, that's also relevant for you as an aerodrome controller or observing for your S1. The CFL is the level that the controller has assigned to the aircraft. So this aircraft departing Sydney has been assigned 5,000 feet as per the Sydney SOPs. That is the correct initial level for jet aircraft at Sydney. You'll also see the runway and the SID star that the aircraft has been cleared. I believe this aircraft was cleared the cabin 7 departure, and that was displaying in here before, but as they've just departed, that is no longer displayed there, and vatSys has removed that. Moving on to the ATC window. The ATC window will just display the current ATC on vatSim for the aerodrome that is selected. Once an ATC has been issued, it'll be yellow like this. This is when the controller reads out the ATC to every station on the frequency, the new change. So any information that has changed from the previous ATC will have a plus to the left of it. So for example, when it's yellow here and this ATC has changed, the broadcast would be something like all stations, Sydney terminal information echo now current, changes, winds 110 degrees, 14 knots, QNH 1008, Sydney terminal information echo. Once that broadcast has been made by the controller, you can middle click that window and it'll go back to its regular red color. So that's the ATC window. Now moving on to the VSCS. We've already discussed how to add frequencies and how to set those as receive. When you're a controller and you're connected with an actual rating to an actual position, you can use the transmit function, and that's how you'd start to transmit on the frequency. If you go back to setup, there's a couple of extra functions. If you click speaker all, that'll set all vatSys audio output to the speaker if you have one defined in your audio settings, as we went through earlier. If you click speaker tones, that'll just be the vatSys alerts. You can also mute your input if you need to step away for a moment, and that'll mute both the frequency input and the coordination input. Moving on to the coord menu. This is where you can coordinate with other controllers. As an observer, you'll only see blue buttons in the coordination menu. Blue buttons are cold lines. A cold line essentially is like a phone call. You click on a cold line to call a controller, they have to answer the phone call. Once they've accepted that phone call, you'll be able to talk to that controller for coordination purposes. Once you're connected as an actual controller, you'll also have yellow buttons there. Those are hotlines. Hotlines don't require the other person to answer, so you just click a hotline and you're instantly connected to that person. They can hear you, you can hear them, and you can coordinate as appropriate. So as an observer, definitely don't touch these. These will call the controller if you click them. If I click Kennedy or Sydney Ground right now, that controller will get a phone call from me as an observer, so there's no need to touch those. Don't confuse those with the frequencies. Make sure if you're trying to listen, say if you want to listen to Sydney Ground, you don't click on the Sydney Ground cold line. You go to setup, add frequency, choose Sydney Ground, and then get the frequency Sydney Ground and set to receive. The final menu is text. This is where you'll see text communications on the frequency. So if you have text pilots on frequency or people just typing for whatever reason, you can see that in there. And as a controller, this is where you can also send messages. The final thing that we'll go through is maps on the ASD, the air situation display. So the ASD will be relevant for you as a tower controller, but also potentially as a ground controller if you're doing things like checking routes for aircraft when you're giving clearances. There are different maps that you can enable. If you go up to maps, here they all are. So the aerodrome maps will be the ones mainly relevant to aerodrome controllers. For example, at the moment, Sydney, the runway nomination is runway 16 left and right for arrivals and departures. That's runway 16 props, not runway 34s. So if I toggle that off and then click on runway 16 props, you'll see that the extended center line for runway 16 is drawn on my display there. What I just did there was called adding a BRL, a bearing range line. Again, not really relevant for tower, ground or delivery controllers, but if you accidentally add one, just click it and then middle click to delete it. We often get questions about how to delete those. You'll see the aircraft call signs here. If you middle click them, you can toggle them to a highlight color. You've obviously got the call sign, the weight category. The left altitude is their current altitude. So Qantas 502 is currently at 5,200 feet, and the right altitude is their cleared altitude, so they're cleared to 5,000 feet. They're climbing above their cleared level at the moment because there's no one to clear them any higher. There's no approach controller online right now, and the initial altitude they were cleared to is 5,000 by the delivery controller. You'll also see this number here is their ground speed, so Qantas 502 is currently at 280 knots ground speed. Some other maps that may be useful for you are the VFR maps. So if you go Sydney VFR, that'll show you all of the VFR waypoints, and if you toggle on full name, that'll show you the full name. For example, as a delivery controller, you may have someone requesting some VFR route into Bankstown. They may be tracking via any one of these waypoints over to Prospect Reservoir or 2RN for Bankstown. Some final other things to mention before the end of the video. Messages and controller messages will bring up your controller messages window. Mine's off here. This is where controllers can communicate and coordinate with each other. The list window will show you every arrival inbound an aerodrome, and it'll also show you the estimated time of arrival. So that might be useful if you're a ground or tower controller and you want to assess when aircraft will arrive for your planning and projecting. If you go to the info menu, there's various tools that you can use. AIS request will allow you to request METARs or TAFs for particular aerodromes. That will be useful for getting an idea of future weather movements and for constructing your ATC. Other windows such as Sim ATC are very helpful. Sometimes you need to open it twice for it to load properly. There we go. Another good one to use is the Route Finder tool. If you need to reference the SOPs, that's also available here. And there are a number of other functions in vatSys that you will be able to experiment with and play with throughout your observation hours. That's really what makes the observation process so valuable, because it does give you a chance to actually interact with the client directly and see how controllers do things on the network. So best of luck, try to get the most out of these hours. It will really help you prepare for your training. G'day.